Today we discuss about the orthogonal transformation. The question is, so that the matrix A given by 1 upon 3 into 1, 2, 2, 2, 1 minus 2 and 2 minus 2, 1 is orthogonal. We know that a matrix is orthogonal, then A into A transpose is equal to A transpose A is equal to I. This is the definition of orthogonal matrix. If any matrix is orthogonal, then A into A transpose, which is equal to A transpose A is equal to I. Now consider A into A transpose. A is given 1 upon 3, 1, 2, 2, 2, 1 minus 2, and 3 minus 2, 2 minus 2, 1. What is the transpose of A? So we have to just change first row, which is equal to first column. Second row is second column. Third row, which is equal to third column. Now we have to multiply these two matrices. So 1 by 3 into 1 by 3, which is equal to 1 by 9. And if we multiply these two matrices, 1 into 1 is 1, 2 into 2 is 4, 2 into 2 is 4. So 1 plus 4 plus 4 plus 4. Similarly, 1 into 2 is 2, 2 into 1 is 2, 2 into minus 2 is minus 4. 1 into 2 is 2, 2 into minus 2 is minus 4, 2 into 1 is 2. Now we multiply in the same manner. 2 into 1 is 2. 1 into 2 is also 2. And minus 2 into 2, which is equal to minus 4. 2 into 2, which is equal to 4. 1 into 1, which is equal to 1. Minus 2 into minus 2, which is equal to 4. Then 2 into 2 is 4. 1 into minus 2 is minus 2. Minus 2 into 1 is minus 2. The last row, 2 into 1 is 2. Minus 2 into 2 is minus 4. And 1 into 2 is equal to 2. 2 into 2 is 4. Minus 2 into 1, which is equal to minus 2. 1 into minus 2 is equal to minus 2. The last element, 2 into 2 is 4. Minus 2 into minus 2 is equal to 4. 1 into 1 into equal to 1. Just look here, 1 plus 4 plus 4 is 9. 2 plus 2 is 4. 4 minus 4 is 0. Same thing, plus 2 plus 2 plus 4 minus 4, 0. Here, this is also 0. This is also 0, 0, 0, and this is 9 and 9. We have 1 upon 9 into 900, 090, and 009, which is equal to, if we divide whole matrix by 9, we are getting 100, 010, and 001, which is equal to I. Similarly, if we consider A transpose into A in the same manner, then also we are able to get its value is nothing but I. So since A transpose A, which is equal to A into A transpose, therefore the given matrix is orthogonal. Now the one question can be also asked that if the given matrix is orthogonal, what is A transpose? What is A inverse? So A inverse is nothing but, if you want to find the A inverse of a matrix, it is nothing but A transpose. So the inverse of A should be the A transpose. This is the inverse of A if the matrix is orthogonal. Thank you.